All right, this is 2.3. And so I'm not going to get to do all of these, but this has Venn diagrams and operations. So we basically have 4 cases. The first case is the set of disjoint sets. So you will have a universal set, which we call U. You will have 2 circles inside that set. One set being A and one set being B, and there is no overlap in sets. So for example, U is the set of all mammals, and A is the set of dogs, and B is the set of cats. Okay, there are no cats that are also classified as a dog, at least as far as I know. Okay, but they all belong to the set of mammals. Okay, so that would be an example of 2 disjoint sets. Then we have case 2, which is going to be subsets. And so we're going to use this little symbol and say that A is contained in B. So we're going to have our universal set here. We're going to call that U. We're going to have a big set B. And then we're going to have a little set A. So this is B and this is A. And A is contained in B. So U is the set of mammals, and B is the set of dogs, and A is the set of poodles. Okay, so all poodles fall into the set of dogs, and all dogs are in the universal set of mammals. Okay, and then we have an example of equal sets, and so we have our universal set here. We put that U up here, and then we have one set A. Let's move that out. Oops. And this is also the set B. So U is mammals, and A is the set of cats, which is the set of B. And then the one that we're going to focus mostly on is going to be the intersection. And that sounds exactly like what it is, overlapping sets. So we have our universal box, and then we have set A, and then we have set B, and they have some common things in here. Okay, so let's say that U is the set of students in Math 103. And let's say A is the set of students with brown hair, and B is the set of students with, let's say, blue eyes. Okay, so this right here, this intersection, A intersect B, and that's how we're going to say, is going to be, is the set of students with brown hair and blue eyes. Okay, so that's how we write intersection. So we're going to be looking at some sets that actually are going to be using that information. Okay, so now we're going to get to the operations of our set. We're going to talk about complement, and it's written like this: A with an apostrophe. So I'm going to draw another box. And I'm going to draw another circle within this box. And it's a good idea if you have a if you have a highlighter. So this will be my set U, and this will be my set A. And if I wanted to shade everything that's in A, which the complement is elements not in A. If I were to shade that, it would be everything that's in the box, but not in the circle. So I'm not going to spend too much time here coloring, but you guys get the idea, okay? Everything in the box, but not the circle. So if we're given this set over here, and this is the set A, we're going to write those elements A, C, and E anywhere in that circle A. And so in the universe, I take A out because I've used that. I take C out and I take E out. And what's left is B, D, F, and G. And it's not really important where you put those, just making sure that the ones that are in the circle are in A, the ones that are not in the circle are not in A. And so if I were to write the complement, which is right here, I will write the complement is anything in the box, but not in the circle. So that would consist of the set B, D, F, and G. Okay? Now we're going to do intersection, and I'm going to draw another box. I think you guys have this in your notes. So this is the universe, this is A, this is B, and the intersection is going to be this area right here. And so the way we write intersection is A intersect B must be in both. Okay? So if I come down here and I write my U, I'm going to draw my two circles. Here's A. Here's B. And now I'm going to look at the given information. So A and B both have a 1 in it, so I'm going to put it in the middle. A and B both have a 3, so that goes in the middle. And A and B both have an 8. So now I have to fill in the rest of A. There's a 2. And the rest of B, there's a 6 and a 7. And so now I have to see what numbers I did not use in the universe. I used 1, 2, 3, 6, 7, and 8. So what's in the universe is 4, 5, 9, and 10. And so my concern is only these right here. So the intersection of A and B would be listed as these elements, okay? All right, the last one I think is a little bit harder. So I'm going to draw another box here, and hopefully we're going to see what that looks like. So we're going to have two circles. So we have the universe, A, B. And so now this one is a little bit tricky. A, B. And if I shade this, it says everything in A, so I color that. It says everything in B, so I color that. Or it could be everything in both. So basically the union is reading everything that are inside those circles, okay? So I'm going to use the same example that I did in that last one. I'm going to go ahead and list these 1, 3, 8, 2, 6, 7. And then that's 4, 5, 9, and 10. And so when I am shading all of these, I'm basically counting all of these numbers. So the union, which is written like this, is going to be the set, and they like them in order. So 1, 2, 3, 6, 7, and 8. Okay? So and is intersection, which is both, and or is union, one or the other or both, okay? And this is a formula that you're going to need to know, okay? The number of elements in the union is going to be the number of elements in A plus the number of elements in B minus the number of elements in the intersection. Okay, so let's look at this up here using this example. So if I look, the number of elements in A is 1, 2, 3, 4. The number of elements in B is 1, 2, 3, 4, 5. The number of elements in the intersection is 3. Okay, number of elements in the intersection is 3. So if I use this formula, there are 4 elements in A, 5 elements in B, take away 3 elements in the intersection, that should equal 6 elements. And if I look up here, I do have 2, 3, 4, 5, 6. So we're going to use this formula to answer these next questions, okay? Now, I use symbols to make it sense. So I'm going to say the number of Spanish speakers, and I'm going to say S for Spanish, is 25. The number of French speakers is 14. And the number of Spanish and French, because it says both, is 4. So I want to know how many speak or. So the number of Spanish or French is the number of Spanish plus the number of French minus the number of both. So as I do this, I have 25 plus 14 minus 4, and that should be 35. Okay, now sometimes they mix it up, and when they mix it up, we're going to just make sure we know what we're looking at. So I'm going to say, okay, we've got hamburger, French fries. So the number that purchased a hamburger or French fries is 28. The number that purchased French fries only is 20. And the number of people that purchased hamburgers and French fries is 17. We are looking for the number of people that purchased a hamburger. So let's write out the formula. The number of or is equal to the number of hamburger plus the number of French fries minus the number of both, which is H and F. So we get number of H is what we don't know, 28. The number of French fries is 20, and the number of both is 17. So now this equals 3 plus number of H equals 28. And so the number of people that purchased just a hamburger is 28 minus 3, or 25. All right, the difference of two sets is this, A minus B. So we have the universe, we have A, we have B. And so the shaded portion of A minus B is we are going to take B out of A. Oh, sorry, that's not right. I messed that one up. Sorry. We have A, and we take B out. Got myself confused here, so it should be this. So this is what we're looking at, okay? So remember, you can't take something out if it's not there. So I want to look at this example right here. And you can do this. You don't necessarily have to do this with a Venn diagram. So what I like to recommend that you do is write your set A, B, D, E, F, G, H. Okay, that's given. Write your set B, A, B, D, H, and I. And remember, you can only take what is NB out of A. So you're going to take out the B, you're going to take out the D, and you're going to take out the H. And so what's left in A are these letters right here. E, F, and G. A and I have no effect on it because they're not in A at all. So we can only take out B that is in A. So we're going to do something similar to with C. We're going to take A and we're going to take C out. So again, I like to write A, and you don't have to put the set line if you don't want to. B, B, D, E, F, G, H. And then I'm going to subtract C out. And C is B, E, and G. So if I cross those out, then what remains is D, F, and H. All right, the Cartesian product. This is a cross product of A times B, where you create a set of ordered pairs A, B, where A is an element of the big set, and B, big set A, and B is the element of the big set B. So if and it does matter importance order, okay? The order does matter. So A cross B is the set. I take the first element in A, and I'm going to abbreviate O, B, A, so I don't have to write this out. And I pair it up with the first element in B. So orange, 1. Then I go back, orange, 2, okay? So I'm done with the orange. Now I go banana, 1, banana, 2. And then I'm done with banana. Apple, 1, apple, 2. And so what I should have, there are 3 elements in A and 2 elements in B. I should have 6 ordered pairs, and I do. 1, 2, 3, 4, 5, 6. Now, if they change the order, B has 2 elements, A has 3. I'm still looking for 6 ordered pairs, but now I'm going to start with the number 1 because B comes first, and go to orange. Number 1, go to banana. Number 1, go to apple. And then I go 2 orange, 2 banana, and 2 apple. Now these are going to be multiple choice, guys, and so make sure that you're looking for the correct number of sets. A lot of times people overcount these sets, and that's too many. Okay, now if we did B cross B, you have 2 elements in B, and you put it together with 2 elements in B, you should have 4 ordered pairs. So I have 1, 1, 1, 2, 2, 1, and 2, 2. Okay? So what I'm going to do here is I'm going to skip around and I'm going to come up here to these problems right here where you're determining sets from a diagram. So I'm going to do this one and probably stop, and then I'll go through and do some more problems, okay? So if I'm looking for the elements that are in set A, I am focusing mostly on this square or circle, okay? So anything that's in that dark blue circle is going to be in A. A, B, C, H, T, W. They do like to have them in alphabetical order. I'm not that concerned with it, but that's how they do it, okay? Now, if I'm looking for the intersection of A and B, I am focusing on this area right here. So the intersection of A and B is what A and B have in common, which is A, H. Then, if I'm looking at the union is going to be everything in both circles, okay? So when I write the union of A and B, now this one I probably wouldn't write in order. I'm just going to W, C, B, T, A, H, F, V, R, D, and G. Now, if you want to write it down first and then put it in alphabetical order, that's fine. To me, that's perfectly fine. You don't have to write it like that. You don't have to write it in alphabetical order, okay? All right, so now this one's a little bit tricky. We want everything that's not in A. That's the complement, okay? Not in A. And then we want to put it together with everything that's not in B, okay? So what I'm going to do is I'm going to come up here and I'm going to shade what's not in A. So it's this and this, okay? That's not in A. So I'm going to write it like this. A complement is the set F, V, R, G, D, and then P, M, Z. Okay. Then I'm going to do the same thing. I'm going to do not in B. And so everything here and in the box is not in B. So B complement is the set W, C, B, T, P, M, Z. And so now I want the intersection of these two groups. So if I look, the intersection is going to be they both have a P, they both have an M, and they both have a Z. And so that is going to be the set P, M, Z. And then last but not least is A take out B. So A take out B is going to be what's right here. And so that would be the set of W, C, B, T. Okay, so hopefully that should give you a start. And then I'm going to come back to these problems and do the remainder problems in a separate video.